For joining us here today for our workshop on teaching statistics with simulation-based inference. My name is Nathan Tintle. It is great to see so many familiar names and faces, as well as a lot of new folks. I'm alongside, well, not physically alongside, but alongside Beth Chance, who's going to be co-presenting with me today as well. So just a few sort of starter requests before we get going. We're anticipating having you all stay muted throughout the call or throughout the workshop today. Feel free to turn off the video if you want. Some of you have it on, some of you have it off. That's fine. I'm probably going to turn my video off here in just a minute so we can stay focused on the slides, and then if there's any connectivity issues or things like that. So the main way we want to interact with you, Beth and I do, would be through the chat window. I already see lots of people introducing themselves and saying where they're from in the chat window. That's awesome. So you can continue to do that. And we do plan on recording this webinar. I think you maybe got a little message about that when you logged in, but we are recording the webinar today for future viewing for all of you, or for others who signed up or wanted access to this, we will be posting it. So just keep that in mind. We'll distribute the link using the email address you registered with here within the next few days. So in terms of the overview, our plan is for about the next hour, maybe a little bit longer, to walk through a number of sort of items here, and then we'll leave some time, substantial time for Q&A at the end, figuring 20 to 30 minutes. So wrapping up about 90 minutes from now. However, as you have questions along the way, don't hesitate to use that chat window and submit your message through the chat window, either directly to Beth Chance or to everyone. We'll do our best to answer some of those questions as we go, but we'll probably hold some of them off till the end. And again, that'll be the bulk of our Q&A time at the end. We're starting with some introductions and goals now. We're then going to go into the motivation for something called simulation-based inference, or SBI, as I'll be calling it throughout the talk today. I'll also talk about the 6 steps for statistical inference and more what we mean by that. We'll walk through then a specific example of a single proportion and how we do that with simulation-based inference. We'll then pull back and say, how does this fit into a whole algebra-based intro to statistics course or other introductory statistics courses at the high school level, at the college level, at the university level. We'll then walk through quickly through a couple other examples on how to compare 2 groups, how to do correlation regression. We'll also show you some new applets that Beth and others on our team have worked to sort of put together on multivariable thinking, and a couple examples there. We'll wrap up with some tips and tricks on teaching online, as well as assessment, both some assessment results from students using these approaches, as well as some ideas for what you can do with your students. And then, like I said, we'll try to wrap everything up here in about 90 minutes, but with a good chunk of Q&A time at the end. So I think that is our plan here. And I think for the time being, I'm going to just mute my video just to make sure that you're all getting the best quality stuff from my end, not using up all my internet bandwidth here at home, which is where I'm coming to you from today, as I'm sure many of you are as well. But I do see a couple nice scenes in the background of views out the window, which are nicer than mine here in Iowa, where it is a mix of snow and sleet and freezing rain today. A little bit about you. We did have a little under 200 people registered as of yesterday afternoon. I know we have some additional folks who registered today. And just wanted to tell you a little bit about yourselves. Typically, when we do workshops like this in person, which was actually our original plan for this workshop, to be in the Chicagoland area today. But we like to kind of do a little bit of around the room introductions and such. I think based on our numbers, we won't do that. So I'll do it for you. We have about half of you from colleges, 4-year colleges and universities, about 30% from 2-year colleges, and about 20% from high school. So that's awesome. And I think just it reflects the diversity of people who are teaching statistics at all these different levels and the importance that it is. Lots of variability in years of experience teaching statistics. That box plot there shows you we've got people who've not taught statistics before, or for who this is their first time, all the way up to people who are in that 30 or 40 years or more years of experience teaching stats. So that's awesome, and I do hope that you can use, feel free to use the chat window also to comment on things you're doing in your class for those folks who are a little more experienced, as well as questions. And we've got 37 different states registered, a few Canadian provinces, and a few other countries as well. So great wide representation across the country, and so thanks for joining us here today. Beth, do you want to take a minute and introduce yourself, and then I'll do the same with a little more formal introduction?
Sure, I'm here in San Luis Obispo at home as well. I've been here, I think, 20 years. They had to cancel our service luncheon, so I'm not going to get my pin in person this year. But yeah, I've been teaching statistics in statistics and mathematics departments for a while now and continue to do so.
All right. Thanks, Beth. So my name is Nathan Tintle. As I've said, I'm at Dordt University, which is in the northwestern corner of Iowa. I'm originally from New York, and I also spent some time in Michigan before I came out here to Iowa. Professor of statistics, and my audio actually wasn't working, so I didn't get to hear Beth's introduction. So hopefully I covered a similar set of things, but now I fixed it. It was my problem, not yours, Beth. And I've been teaching statistics now since I finished graduate school, where I got a PhD in statistics back in 2005. So our goals for you today really are to do kind of a wide-ranging taste. So when we do these workshops, sometimes we do them in a shorter format like this, 60 to 90 minutes. Other times we'll do a full day. And so obviously in a shorter format like this one, we're going to kind of try to hit the highlights of a number of different areas. And so really just kind of whet your appetite and then hopefully point you to a wide variety of free resources that you can go learn more. So additional papers you can read, free web applets, we'll talk about those, free activities you can do with your students and such. So wide-ranging introduction. So please ask those questions so we know where we can dig deeper on some things, and then also point you to some of those free resources. So maybe to start, we'll just talk a little bit about our motivation for doing things differently. And I'll take a few minutes on this, and then I'll invite Beth as well to jump in and share a little bit about her motivations. You know, when I started teaching introductory statistics in graduate school in the early 2000s, and then my first few years in an academic appointment at the college level, the course I taught started with descriptive statistics, and then it moved to probability and sampling distributions, and then it moved into inferential procedures like confidence intervals and tests of significance. And that still remains the standard curricular approach around the country and around the world. And what was interesting is when I was teaching my students this, the beginning of the semester always went really well. Students were happy and excited, and we were dealing with real data, and it was fun. And then there was this day in the semester, and I circled it on the calendar. I'd know when it was, where we would kind of turn the page in the book, and the next chapter would be probability. And you know, all that kind of enthusiasm and excitement from the first part of the course would go away, and student attitudes would change rather dramatically. And you kind of got this sense of, I knew this was going to be a math course, and here it is, and this is going to be hard, it's going to be abstract, I'm not going to understand it. By the time we got to the last part of the course on inference, students were sort of hanging on for dear life mode, you know, just trying to memorize, just try to get by, wrap this thing up so they can move on to the next thing. And this was kind of disconcerting to me. I didn't really like that approach. And so when, you know, I get students studying for the final exam, they'd be coming to my office hours asking me questions about, you know, what are the conditions for a chi-squared test? And kind of like, look, you're a C student. That's not the kind of question that's going to get you a good enough grade on the exam. You've got bigger questions you should be asking than these little technical minutia. And why are you trying to memorize whether it's big p-value or small p-value? Isn't there something more important here for you to understand about the role p-value tells us about strength of evidence than just trying to memorize a rule or memorizing an algorithm? You know, and I remember seeing curricula and even teaching them at times where, you know, step 1, do this, step 2, do this, step 3, do this. And it was a rule book and a cookbook to follow, and thought, man, my view of statistics is this wonderful way of trying to make sense of the data we see in our world and draw conclusions from it. And I think it's awesome to have this structured way to go about that process. And yet my students aren't leaving with any of that enthusiasm. Not that I live in such a, you know, a world where I think every student is going to love the same things I do, but why aren't some of my students grasping some of that same passion and understanding the big picture here? Why are they getting so stuck in the minutia? So Beth, do you want to jump in a little bit on some of your experiences?
Yeah, some were similar in that, you know, students would come at the end of the course and that from the questions they were asking, you got the impression that because they were focusing on minutia, they weren't seeing that big picture. Like they'd be very proud of themselves. I have this p-value. I know it's important, but what do I do with it? Do I want it to be large or small? And so what I started doing was more simulation, especially when I was introducing sampling distributions. And I had a friend write a little applet that looked at Reese's Pieces, and students loved it because we got to do the tactile simulation with the candies, but then we could go to the technology and very quickly change things and see how that impacted the behavior. And they were able to start seeing a little bit how that was used to make decisions, and they just got such a much better understanding of the p-value. And kind of the first thing I did to radically change my course was to put that chapter on collecting data first, to again help them see how this is used out in the real world, but also to give them some of that confidence that you can critique these studies, you have some of that intuition. And so I started to realize that if I'm going to start with those questions, I wanted to be able to answer those questions as quickly as possible. And as we'll hopefully illustrate today, using the simulations, even just informally at first, really get students to answer some of those questions and to be able to tell that entire story, rather than saying, okay, you'll learn these pieces, and by the end of the term, you'll be able to put it all together when you're rushed and worried about finals and all your other classes. So I just felt this idea of the active learning really improving how we were teaching statistics, and the technology really advancing to be much more feasible for students to be able to use it and make sense of it and make sense of statistics using the technology, just kind of all suddenly came together, and it became a much more feasible approach.
Yeah, and I think I can resonate with a lot of what you said also, Beth. You know, I thought of a couple other things. When I was getting this sense of discontent that my students weren't really getting it, one of the things I did was collect data on my students. And what we saw were some interesting trends. We saw that the students who were coming into our course actually knew a good number of things about descriptive statistics from their high school experience before they even stepped foot in my course. And I thought, well, that's one reason everyone's having fun here at the beginning of the course. You know, I'm not realizing that they already know some of these things. Now, of course, there were some very glaring weaknesses, things that I thought if you knew, you know, this concept of descriptive statistics, why don't you know this other one? What we've seen in the data is that a lot of that can even be state by state dependent based on the high school curricula that the students are seeing. But by and large, there were descriptive statistics things I was teaching that students had already seen. And even now, I think that's working its way back even to the elementary and middle school curricula. That's the age of my kids right now. And it's awesome and exciting to see some of the things they're doing there. Actually, now in this sort of school at home environment we're in, I was just helping my son with some things on probability, and he's in 7th grade. And I thought, wow, this is stuff I used to teach or try not to teach at the high school level. You're seeing this in 7th grade. That's awesome. So I think this idea that we need to adapt to the fact that things are changing at the middle school and high school level. And, you know, another thing that I was seeing, so I do biostatistics and genetics research as my sort of as a practicing statistician. And I was actually using simulations more and more in my own research to model sampling distributions and working with undergraduate students doing the research. And while that was a select group of students, I was just seeing the benefit to how simple this made hypothesis testing and significance testing and bootstrapping for confidence intervals. Even with the more advanced students, it was giving them intuition that they didn't have coming out of their traditional statistics background. So as we've said, so we're kind of motivated to this new way, and Beth started alluding to some of these things. You know, can we get more simulation in there? Can we try to keep students closer to the data? A big idea is trying to keep the main thing the main thing. And so we felt like what students often missed in this more compartmentalized descriptive statistics, then sampling distributions and probability, and then inference at the end was sort of this picture that statistics really was a cohesive whole. And so we'll talk here in a few minutes about something we call the 6-step approach to statistical investigations. And while other people have 4 steps or 5 steps, we think this idea of teaching statistics as an entire investigation process helps students not get lost in so many of the details and see statistics really as a cohesive whole. And then we're going to spiral over some key ideas throughout the semester. So trying to figure out what are those few key conceptual ideas, get them in front of students early in the semester and go over and over and over them as we go. And then making sure that those things we're going over and over and over are more conceptual versus algorithmic. That's where we think the simulation-based inference stuff can really help. We'll talk more about that as we go. Trying to reduce some of the typical, we'll call it mathematical overhead of equations, notations, terminology, rules, algorithms. Yes, there's going to have to be some of that, and that's okay, but really trying to be very judicious as to when we do some of that. And then, as we've alluded to, trying to be more statistical focused as opposed to probabilistic. So when we look at that probability and sampling distribution part of the course, thinking about how can we instead keep close to the data? And this is really where simulation-based inference, I think, has the most to offer, is keeping students close to the data, building empirical sampling distributions that are tied to your data set and your example, rather than jumping immediately into, the theory of the central limit theorem. We're going to do the central limit theorem. We're going to do these same key sampling ideas, but we're going to do them in a way using simulation that we think is more intuitive for students. So let's, well, before I walk through an example, I'll just briefly mention that we think this is not only aligned with, but really fundamentally embracing the GAZE guidelines, which were first around 2005 and then renewed in 2016. But these ideas of teaching statistics as an investigation process, we'll talk a little bit about multivariable thinking in a little while, conceptual understanding, context and a purpose, and active learning, and those others as well are really inherent into what we're calling the simulation-based inference approach. And we'll see that hopefully as we go here. So we've taken these ideas and they are really at the core of a few different curricula that we've put out there. We're going to go to this website later in our time together, ISI-Stats.com. The first book that we published, Introduction to Statistical Investigations, which is up there on the top left of your screen, is an algebra-based introductory statistics course that uses simulation-based inference. We'll talk more about what that looks like in terms of curricular content, but it gets students to the same end place as a typical introductory statistics course. And so they're still going to see t-tests and chi-square tests and ANOVA and such at the end of the course. We have an AP version of that curriculum that explicitly gets at all of the different standards and sort of needs for the AP curriculum. That came out just within the last couple of years. And we have a new book that's in preliminary edition called Intermediate Statistical Investigations that is a second course. And so it takes what the students saw in the introductory course and then builds on that, really getting at multivariable thinking as the main focus. But it's only that introduction to statistical investigations course that's the prerequisite. And so we see this as an emerging set, or sort of an emerging need for our students to do more with multivariable thinking, but not have to take more formal mathematical prerequisites. And so students don't have to take calculus or linear algebra, these other things that I needed to take before, when I was in upper level undergrad and in graduate school, I had to take all these other math courses before I got into multivariable modeling and such. And we're showing you here's how we can do this. So we'll talk more about that course as well. So at this point, I hope you're asking, so what does this actually look like? This is great in theory, you've explained the motivation, you've got these curriculum, what does this look like? So what I want to do is walk you through in a very concrete way an example. Before I do that, I'll just mention we've got some great questions coming in on the chat. And so I'd encourage you as we go, if you have questions, please enter them in the chat window. Beth's answering some of those as we go, which is great. We'll have a more open Q&A at the end, but Beth can jump in at any time if she wants to, throw another question in, or if I have a minute and I see something that's right on point with what we're talking about, we'll tackle those as we go. All right, so now we're going to jump into our first example, a single proportion inference with simulation-based inference. So this is a study and really a story that I tell students very early in the semester. In my course, typically we have 1 or 2 class periods, kind of doing a little bit of introductory preliminary stuff, going over the syllabus, a little bit of content on the 6-step method, which we'll talk more about in a minute. And then we're into this example. And so I open up class by telling students a story. Say, we know a lot about the fact that animals communicate. Birds chirp when we walk outside, telling us to get away from their nests during this time of year. I've got a dog at home that communicates to me, wagging her tail, barking, and things like this. So we know that animals communicate, but there's a whole line of research that looks at the way animals communicate, and the limits of that communication. And so some really interesting work's been done with dolphins that we would typically think of as a more advanced species, and so perhaps they can communicate more advanced ideas. And so we're going to tell you a story about a study that was done by a marine biologist at UC Davis, and he really wanted to understand what kinds of abstract ideas, or whether dolphins even could communicate abstract ideas to each other. And so what this biologist, Dr. Bastian, did was he had two dolphins. He captured them from the wild, a female dolphin, which he named Doris, and a male dolphin that he named Buzz. And he brought these dolphins in from the wild and essentially put them in a big tank, like you've seen at the zoo. Over time, he trained these dolphins. And so, as you've seen, if you've ever seen a dolphin show, you can train dolphins to respond to different kinds of cues. Some of those cues are audible and some of them are visual. And so what Dr. Bastian did was he trained these dolphins to respond to a visual cue. So what you see in the middle of your screen is a light. It's meant to represent a light that's on. And when that light in the pool came on, so this light was sort of on the wall of the pool, the dolphins were trained to push a button underwater with their snout, the button on the right-hand side of your screen. So if the light's on, they push the button on the right. On the other hand, if the light is flashing on and off, then the dolphin is supposed to push the button on the left. So if the light comes on and it glows, you push the button on the right. If the light flashes, you push the button on the left. Now, once he was convinced that these two dolphins knew this visual cue and their expected response, he was ready to do the experiment. So both Doris and Buzz are in the pool. And what Dr. Bastian does is he takes the light away from the side where Buzz is, and he takes the buttons away from the side where Doris is, and he puts a barrier down through the middle of the pool. And he turns the light on, and the light is flashing. And Doris can see that light, and Buzz can't see the light, but Buzz has access to the buttons. So the light's flashing, Doris sees this. What's she gonna do? So she makes some squeaky noises, and Buzz swims over and pushes the correct button, the button on the left. So to review, the light has flashed, Doris can see this, she squeaks, and Buzz, who's on the other side of this opaque curtain and can't see the light, swims over and pushes the button on the left. Now that's the correct choice. That's the right thing to do when the light is just flashing. And so they both get a fish. Now, the researcher knows that this is interesting, but it's only one time. So he then goes and proceeds to repeat this 15 more times. And out of the total 16 times that Dr. Bastian does this experiment, Buzz pushes the correct button 15 out of 16 times. So I tell the students this story to my students, and then I ask them the question, do you think dolphins can communicate abstract ideas? And I have the students say, talk to the people at your table or the people next to you about that question. And they brainstorm, and usually I hear things like, well, we don't really know what you mean by abstract ideas. And I say, okay, I'm willing to clarify a little bit more, and we go through that discussion process. Do you think Buzz knew which button to push? Right? Do you think that Doris communicated to Buzz which button to push? So my students like saying it's the female dolphin communicating to the male dolphin. That's a very important part of the experiment. So we talk about some of the study design, and the students have these great questions, and they critique it, and they ask things like, well, what do you think? Do you think Buzz could actually see through that curtain in the middle? And it's all good stuff. And we sort of refine the question down, and we get to the heart of it, and we say, look, we're going to assume that the study was well designed. I've read the paper. The students can go read the paper if they want. It goes through all those technical details. Let's assume the study is well designed. And let's just talk about these two dolphins, right? We have that discussion about, we're not talking about all dolphins here. We're talking about two dolphins. We're talking about Doris, a female dolphin communicating to Buzz, a male dolphin. And if we refine this question down and we say, do you think Buzz knew which button to push? And we ask the students, most students say, yeah, we do. We think that Buzz somehow knew which button to push. I say, well, why do you think that? I want you to think for a minute about what your students might say in answer to that question. While you're thinking about that, what I want to do is I want to show you a video I'm just going to click a button here to be able to share my computer sound with you. So I can share a video. Recently, I had a video crew come into my classroom, and I told the same story you just heard, and then we recorded what the students had to say. So let's watch together.
Out of the next 16 times, Buzz pushes the correct button 15 out of 16 times. And so my question for you is, if Buzz pushes the correct button 15 out of 16 times, do you think that dolphins can communicate abstract ideas? So here's what I want you to do now. I want you to, with a partner, okay, 1 or 2 people next to you, talk about that question. Based on the story I've told you, based on what you know, do you think dolphins can communicate abstract ideas? So we're going to take 2 or 3 minutes and have you discuss that in a small group, and then I want your groups to be ready to share sort of some of your thinking on this, okay? All right, we'll take another like 20 or 30 seconds or so, and then we'll have your individual groups share a little bit. All right, let's have some sharing. So the question is, we have this researcher, he does this study, we observe the data, 15 out of 16 times Buzz pushes the correct button, and the question is, the researcher's interested, can dolphins communicate abstract ideas?
We were just saying that we do believe that dolphins can communicate abstract ideas, because if it was just random choice, there would be a 50-50 chance that he could choose the right button, but 15 out of 16 is a lot bigger gap between 50% and whatever 15 out of 16 is, so therefore we do believe that the dolphins can communicate in some type of way to choose the right button.
How could we show that to someone? How could we demonstrate that? Does anyone have any ideas about how we could demonstrate that to someone? Yeah.
You could run some sort of trial, like where you flip a coin maybe 16 times so that you have a 50-50 chance of getting one result and see what you get.
So what I love about this example is that students' intuition is correct, that they understand that 15 out of 16 is not the kind of thing that happens just by chance if Buzz is just randomly guessing. And I hope you can appreciate too that students can, as you saw in this example, we've got the clip of the student who says, well, it's like flipping a coin, or it's like I randomly guessed on that true-false test that I didn't study for, or it's like I'm playing a card game. They can say that 15 out of 16 is not the kind of thing you would expect to happen if the dolphin was just guessing. You say, well, what kinds of things would happen if the dolphin was just guessing? And the students will say, well, things like numbers like 8, 9, or 10. Go ahead, Beth.
Can you clarify when this happened in your class?
Yeah, so just to reiterate, this is on day 3 of my class. So day 1, we do a little bit of, syllabus, getting ready for the class and talking about the 6 steps. Day 2, we do a little bit on variation in data and how that's a core part of what we do. And then we jump right into this study on day 3. And what I love about it is, here we've done really an informal inference on day 1. We didn't talk about null hypothesis. We didn't talk about alternative hypothesis and p-value. I'll show you a little bit more how we go on with this. So there's 2 possible reasons why Buzz chose the correct button so many times. He might be randomly guessing, and he got 15 out of 16 correct just by chance. Or maybe he's doing something other than guessing, and maybe he's understanding what Doris was telling him. So what we talk about with the students is, we say, okay, your gut feeling is that 15 out of 16 is unexpected. How could you show that to someone? And they talk about the coins. And so then we walk through with the students live in that kind of group setting. Okay, so what does a coin flip represent? Well, that represents a guess by Buzz. What does heads represent? What does tails represent? And then what are we going to do to simulate this study? And so what I'll have the students do is each student will flip a coin 16 times. They will get their number of correct choices, and they'll go up to the board and they'll make a dot for how many correct choices they got. And so I'm going to just show you now an applet we have, but essentially what we have the students do is that, yeah, they flip their 16 coins, they get the number of heads, they come up and plot it on the board. And what we see is, you know, most of the students get numbers around 8, 9, 10. Some of the students might get as big as 12 or 13. Of course, it's possible you get 15 out of 16 when you're flipping the coin, but it's pretty unlikely. Once we do that as a class, I'm fortunate most of my classes are 30 to 40 students, but I know some people do this with classes that are much bigger. But we say, you know what, that was 30 or 40, maybe even 60 or 70 coin flips. Have you really, you know, have you convinced that skeptic in your class who says, no, I need more data? And that's where we turn to the computer and we say, you know, we can flip coins, but we can also have a computer flip coins. And we're showing you now one of our free applets. You can get to this off the ISI-Stats page. I'll show you in a minute just a little bit more exactly how to get here. But we're on the one proportion applet page. And this applet, whoops, I need to change the number of tosses to 16. Okay, it will flip 16 coins for you. And now it's flipping these 16 coins, and the computer got 10 heads. And maybe what you can see down here at the bottom, I'll try to zoom in a little bit for you. You can see down here at the bottom is a little dot for 10 heads. And we'll tell the class, this picture, that dot is exactly what you just did. The computer just flipped a coin 16 times and came and made a dot here at 10. Now the computer did exactly what you just did. But the beauty is the computer can do lots of coin flips really fast. And so we then do many coin flips. We do this as a group. We say, oh, look, what do we see? We see that you don't really get numbers like 15 out of 16 too often if you're flipping a coin, which means that when Buzz pushes that correct button 15 out of 16 times, it's pretty strong evidence that he wasn't just guessing, that something else is going on. So we're doing this on approximately day 3 of the class. We've done a test of significance. We've got a null alternative hypothesis. We've got a sort of a pseudo p-value. We're way out in the tail of the distribution anyway. And we haven't used any of those terms. We haven't used the term sampling distribution or binomial either. This gives us a foundation on which we can then layer all of these other concepts as we go. So from here, we can then talk to students in the next class about null and alternative hypothesis. And maybe the class after that, we can talk about p-value. And then later, if we want to talk about binomial distributions, we can. We'll talk about the normal approximation of the binomial, et cetera, et cetera. But the core idea is really something that we call the 3S strategy. And this is one of the ideas we come back to and spiral over and over and over again throughout the semester. The first S is statistic. We're going to compute a statistic from the observed data. In this case, our statistic was 15 out of 16. Then we're going to simulate. We're going to identify a model that represents a chance explanation. In this case, it was a coin flip. We're going to flip it 16 times. Then we're going to repeat that many times so we can evaluate the strength of evidence. That's our third S. We're going to evaluate whether the value of the observed statistic is unlikely to occur based on the results of those simulations. We're using and introducing the 3S strategy in that first week of class, and we're going to talk about it the rest of the time we have together. That's one of the things we spiral over. And the beauty of simulation is it has the ability to say, look, this 3S strategy works, whether you're doing a simple one proportion test like we did here, or you're comparing two groups, or you're looking at correlation, or whatever the case is, you can follow this approach. This is just a little more of the instructions of how to get to the applet, the ISI-Stats.com page. Click on Introduction to Statistical Investigations, applets, and then one proportion applet. I see that Beth put the link in the chat box as well. What I actually do on the first day of class is talk about the 6 steps. And I emphasized earlier the importance of the overarching research process. And we like thinking of this as the 6 steps of a statistical investigation. And they're on the screen for you. And so whenever we introduce a new story, we talk about the 6 steps. And this is another one of those things that we're spiraling over all semester long. We're asking a research question, we're designing a study and collecting data, and then we're walking through, exploring the data, drawing inferences, formulating conclusions, and at the end, we're looking back and ahead. I really want to emphasize that last point with you for a minute, because when we think of that Doris and Buzz study, when we end the class period and we say, yeah, we've got pretty strong evidence here that Buzz is doing something other than guessing, I ask the students, okay, so what were those assumptions we made early on? Remember those assumptions about study design and what was right and what was wrong, or things we didn't know? And then what do you want to do next? What's your next study? And some of the students might say, well, I want to see if Buzz can communicate to Doris just as effectively, right? Or we want to try this with other dolphins, or we want to change up the visual cue, or whatever it is. And so some great questions there. And that's an opportunity to kind of pull students out of the weeds if you need to, pull back to this place where they're going to be comfortable answering your questions. What I love about this study, the Doris and Buzz study, is even the students who come into my class, the most intimidated by math, the most, with maybe the most sort of the worst experiences of math in their background. I actually get a list of some of the students who go through an extra prerequisite course because they need a little extra support before they were ready. Those students will regularly engage these studies in sort of a class discussion, which I think is awesome. So how does this work into our overall curriculum? So I kind of told you what we're doing the first week. The rest of the first part of the course is going to continue to emphasize simulation, but it's going to walk through what we call the 4 pillars of statistical inference. And so we've got inference in the way we just showed you here, estimation, which is confidence intervals, generalizability, taking samples from populations and generalizing, and then causation, cause and effect. We do those, what we call the 4 pillars of statistical inference first, saying these are the most important ideas. So we're going to spend a chapter on each of them. And then the remaining chapters, we organize the chapters by the type of study. And so what that allows us to do in those remaining chapters is sort of encapsulate study design, descriptive statistics, simulation-based inference, and theory-based inference all in one chapter. So we see, so students see how this is really all one cohesive picture. And so by the end of the course, students have seen all the usual stuff. They've still gotten to t-tests and chi-square, which is probably what one of your client departments wants your students to see. We're using a different scaffolding to get there. But we argue that they're getting the same things by the end, and that this is a stronger conceptual foundation. We'll show you some assessment data here in a few minutes. Again, the website, sample chapters, materials, curriculum overview, additional videos, applets, and all that good stuff is there. That's kind of a content overview, but what about a pedagogy overview? In these curricula, not only this one, but also the AP edition, as well as the second course, we use something called guided discovery explorations. The Doris and Buzz example is a good example of what I'll call an interactive lecture, but a lot of my class periods, the students are actually working on these guided discovery explorations. These are open-ended questions that the students answer. In sequence, we've scripted them out for them. They walk through, they answer all these questions. And by answering these questions, that we are guiding them through the discovery of these statistical concepts. We talked about spiraling a number of times, the importance of going over these key ideas numerous times. We talked about the pillars of statistical investigations and how we're going to start there with inference, estimation, generalizability, and causation. And then we're going to spiral over those ideas by asking some key questions about generalizability, causation, and those other topics with every study. And that brings up the point there on real data. We are using real data, real studies consistently throughout the course. I really enjoy, and I know my students enjoy, looking at colors of M&Ms and eating cookies and doing these kinds of things. We still do a little of that, but I've really been convinced that more often than not, we should be showing real studies from the media, things that are, or in the scientific literature, things that are relevant to students and show the power and beauty of statistics. I think we've had some great discussions on some of the statistics listservs over the last few weeks about how much we want to engage students with data on the COVID-19 crisis and the opportunity it is. We also want to be sensitive that, students don't always want to be talking about all of those things all the time. But if it's done in the right way, that this is a wonderful opportunity to talk about the power of data and sampling bias and the power of scientific reasoning and statistical reasoning. And so something we try to do. The Doris and Buzz study, it's both accessible, it's real, it's also engaging and simple enough that students can wrap their head around it. And then lastly, it's based on assessment data. And we really tried to use assessment data, what we saw about student performance, to guide our development of the curricular materials. And again, we'll show you a little bit of assessment data here in just a couple of minutes. We're now going to just take a minute and quickly go through a couple of other demonstrations, not nearly as long as the Doris and Buzz study, but just to give you a taste of what does simulation look like later in the course. And so by this time, halfway through the course, the students are familiar with the 3S process of statistics, simulate, and strength of evidence. But what we're doing then in the second half of the course is looking at 2-variable inference. And so, our null hypothesis is no association. And so we ask the students, brainstorm, how are you going to summarize associations? So maybe it's the difference of group means, or maybe it's the slope of the regression line. And students are great at coming up with that statistic that they want to use. And by using, for example, the difference in group means as opposed to the t-statistic right away, because they're not going to be able to just brainstorm t-statistic. What they can brainstorm is, if I want to compare these two groups, I could look at the difference in the means. That makes sense to me. And then we say, how are you going to simulate this to show no association? I'm going to show you in the applet in just a minute how the applet visualizes this. We do things with cards in our class as a tactile demonstration. And then we're going to compare the study statistic to the simulated results. We're going to start with experiments, where shuffling matches the study design. So let me show you a couple of other applets here. So this is our Introduction to Statistical Investigations website. Click on applets, and we'll go to the multiple means applet. So this is a study that was published, I think, in Nature, looking at sleep deprivation. It's a randomized experiment with 21 people. I don't have time to go through all of the details of this study design, aside from saying we've got 10 people in one group and then 11 people in the other group, and the scores are a little different between these groups. This applet allows you to paste in your data. Some data sets come preloaded in the applets, but you can paste any data set you want into the applets. You can click on and off on box plots if you wish, and we see the means of the groups. What I wanted to show you here is when I start with my students, the first time we compare two groups, I have them use slips of paper. So we would write down the 21 scores. We would shuffle those 21 slips of paper, one score on each piece of paper, and deal them into two groups, 11 in one group and 10 in the other group, representing the random assignment of this experiment. But our applet visualizes then re-randomization, which is our simulation model. And so hopefully you'll be able to see this in sort of as the applet's doing this. The applet is showing you how to shuffle and deal those 21 scores into the two groups. And as we shuffle and deal, and those red and black dots are moving around and going back to the two groups, you'll see we're adding values over here. This is the shuffle difference in means. And so every time we do this shuffle and deal, we get a new value of the statistic. So if we do lots of shuffles, we'll get a simulated distribution representing, zoom in on this a little bit for you, representing the kinds of differences in means that we would expect to happen just by chance. And as it turns out in this case, the observed difference in means was 15.92. And so here we have an empirical p-value of 0.003. Obviously, I'm going through this real fast with you. I hope that, after we're done, you can play around with these applets and see some of our materials that walk through this a little bit more slowly. Really quickly, I will click on the correlation regression applet just off that little toolbar up there at the top for correlation regression. Again, it comes preloaded with some data. This is on foot length and height of people, so each dot represents a person. You can show the regression line. You can do some really cool stuff here with moving the line around and trying to minimize residuals and things like that. What I wanted to show you was, again, we can do some shuffling. And so we will just show you how we can shuffle those response variable values and build our empirical null distribution over here on the right. I'll do a bunch of shuffles. And again, this is going to allow us to estimate our p-value by seeing how, in this case, the slope of the data, the slope of the observed data, which was 1.03, how that's a pretty extreme result if the null hypothesis is true, where the null hypothesis is no association. So again, we're keeping it very abbreviated on these other applet demos. There's a whole bunch of applets up there on the top of your screen, and I hope when we're done here today, you can go play around, check these out. Really important note about all these applets. They're all freely available off the website. They're JavaScript. They work on students' phones, tablets, laptops, whatever. which makes it really convenient for students to access these whenever, wherever. And again, students can post in their own data. So we have a bunch of data sets that come preloaded. We've got other data sets in our curricula that students can copy and paste in, but any data set will work. So key take homes, accessible and freely available applets, as we've talked about. I saw a question from a few minutes ago on the chat window about accessibility, and Beth answered that there, so feel free to scroll through and read more about that. Available on virtually any device. Really want to emphasize the fact that so many students want to make their technology a black box. And so, they just want to push buttons on the computer, the calculator, whatever it is, and just kind of hope for a miracle. And we've tried to build these applets to scaffold off of what you've done in class. So if in class students are flipping coins, what they see in the computer is a computer flipping coins, right? So we're building on that. If in class the students are shuffling cards or shuffling slips of paper, then the computer's doing this. I should note that I keep saying in class, and probably you, like me and everyone else in the United States right now, you're teaching online, maybe you're saying, so how do you do a tactile demonstration online? Well, I've done this in different ways. I've actually taken video of myself flipping the coin or shuffling the cards for students. I've written guided discovery activities for the students that say, now it's your turn, go get a deck of cards. Yes, I really mean it. Go get a deck of cards, do the shuffling or whatever it is. Really see value in, if they've had that tactile experience, then turning to technology makes what the technology is doing so much more real, especially when the technology is visually showing you exactly what you did yourself by hand. A lot of people at this point ask, well, that's all great, but you know what? The psychology department tells me I need to do ANOVA. And I don't see how this approach with simulation is going to get my students to ANOVA. Well, I want to go back to the applets for just a moment. Drag this back over here. One of the things we've tried to do in these applets is give you the ability to choose standardized statistics. So obviously in real statistical, I shouldn't say real statistical practice, in traditional statistical practice, we would use a T statistic or R squared or F statistic as our statistic that we're going to do inference on. When you choose one of those, you have the ability to overlay the theoretical distribution. So I said overlay the T distribution. This is now the mathematical prediction of what you would have gotten if you had simulated. So I tell my students, look, the simulation stuff's cool, it's powerful, it gives you incredible opportunity, but up until 15, 20 years ago, we didn't have the computer power to do it. We didn't have the technology to do it. So for 100+ years of statistical practice, people needed mathematical predictions of what would have happened if you'd simulated. Those mathematical predictions, as you can see in this case, it's a pretty good prediction. The shuffled statistics really match that theory-based mathematical prediction of the T distribution. Why is that? Well, that's because these validity conditions are met. And just get back to my slides here. That's because certain conditions are met about sample size and skewness and those typical things. What's interesting is we can actually now with students, they can visually see by overlaying the distribution when the validity conditions aren't met. It's one of the biggest questions I used to get. Well, I don't know, is this data skewed or not? Well, if you're not sure, do the simulation, look to see how close your theoretical distribution matches your simulated distribution, and you'll get a sense of how much that skewness in the data set really impacted your downstream inference, your downstream conclusions. Plus, students have an alternative when the mathematical prediction isn't valid. So in those cases where you say, actually, I'm getting pretty different results here between my simulation and my theory-based prediction, you have an alternative of what to do in those cases. I don't want to make it sound like there's no assumptions or conditions for the simulation-based methods. Obviously there are. We do talk about those with students somewhat, but this idea that some of those gray areas on skewness and sample size and things become almost a moot point in this curriculum, which to me is a good thing. All right. So I think
and Nathan, David also brought up the point about how you can look at other statistics like medians and mean absolute deviation.
Oh, wonderful point. And I love how seamless that is in the applet. It's just a button click to go to median. And isn't it nice? And we talk about medians, like in a typical stats course, you start with descriptive statistics and you're like, hey, the median's great, it's resistant to skewness and outliers. And then the whole second half of the course, we're never going to talk about median again. And now if you're comparing two groups, you want to compare the medians? Go for it. Button click different statistic. There you are. And it actually, what's fascinating to me is it allows you to get into these really deeper statistical ideas like anticipating statistical power and robust statistics and these things, sufficient statistics. We're not actually doing the theory of those things, but my intro stat students are anticipating those ideas. And that's what excites me probably most about this curriculum. Students are doing statistical things closer to what I'm doing in practice as a statistician. And I compare that to what my students used to do when I was teaching the traditional way, and it's pretty exciting. Quick little note here on multivariable thinking. It was always important. It's just becoming more and more important, in a really big data kind of world. It's part of the GAZE guidelines to have a little more experience in multivariable thinking. And really what we've done is we've added some additional emphasis in the second edition of our first course. It was already there. We've done a little bit more with it. We've got a second edition coming out next January. We've also added a second course. I talked about this or alluded to this a little while ago. And in this second course called Intermediate Statistical Investigations, it's a full-length second course for after any algebra-based first course. It uses our same pedagogy and our same conceptual approach, but you can use it whether you're using our first course or any other first course textbooks. I'm just going to briefly show you a couple of the new applets from that book. And so if you just go to our main ISI-Stats.com page, we've been working mainly here in the upper left, the Introduction to Statistical Investigations textbook, but now we're going to go down to Intermediate Statistical Investigations. We do have a preliminary edition out there right now. I know a number of people are using it. And so if you're interested more in that, we'll have some information for you in a minute as to how to get a copy of that and learn more. But there's applets and data sets for the intermediate course. And so I'm going to click on that. I'll just show you two of these applets briefly. One is this multivariables applet. This applet allows you to drag and drop variables here. We've actually got that same height and foot size one we were looking at just a minute ago, same scatter plot idea. But now if I want to do things like, let's see, for color by a categorical variable, okay, I can do that. Or let's drag another quantitative variable, here's hand span, over, and we're going to color by hand span. And so you get this multivariable graphical tool. We then build on that in our second course by talking about attributing variation to different sources with then sort of multivariable models and ANOVA and sums of squares and such. This also allows us to look at different adjusted values in our plots. So lots of functionality here. We're really excited. I've been using this more and more with my students, and we're excited about that. Another one that we use in our second course is on blocking. I wanted to just show you this one because, as you move into more advanced statistical concepts with students like a randomized complete block design, you say, well, how does simulation work in that environment? And what I actually have my students do is, say, well, what have you been doing before? Well, when you simulated, you re-randomize. So if it was a randomized experiment with just, treatment and a control, you'd re-randomize to those two groups. In a block design, we're going to re-randomize within the blocks. And so what the students can visualize is, and I don't know if you'll be able to see this on your computers, hopefully so, but what we have now is shuffling going on within each of the 5 blocks. And so there's five blocks in this study. I'll just do that again. And so the students can see how now we're going to re-randomize within the blocks. And when we do that, we get, we're going to again build up this null distribution of shuffled statistics. This applet also allows you to show block effects and adjust data for block effects and things like that. And again, in the interest of time, I'm going to move on from those features and functions. So a couple of kind of concluding remarks here as we wind down, and then we'll move into a good time of Q&A. First of all, teaching online. We get a lot of people saying, especially over the last few weeks, how do you teach this online? I'm used to standing in front of my class and all this tactile stuff and conceptual learning. Does that work online? Absolutely. I've taught online before. Beth's taught online before. We each have our own style there, and I encourage you as you are teaching online to think about what's your style, what's working for you. But here's a few tips and tricks. Those applets are actually embeddable. They're JavaScript. You can reach out to Beth on the chat window or offline and get more information about that. Our curriculum has something called Wiley Plus. It's part of the Wiley textbook family, which means that there are videos that go along with every section. You have multiple videos per section. Most of the videos are between 2 and 5 minutes long. So I know when I'm teaching online, I tell the students, hey, instead of reading the book, you can read if you want, or you can watch these videos, which essentially guide you through the reading. There's a fully accessible ebook, as you might imagine. We have those guided discovery explorations in a fillable PDF format, so my students can type their answers in there and submit them online. Also, a large online homework, auto-graded homework system. One of the things Wiley did, and I know some of you maybe are joining us again, we gave a workshop on this or a talk on this just a couple weeks ago. Wiley Plus is now free for the rest of the semester. If you're trying to sort of figure out how do I do online stuff, reach out to your Wiley rep or reach out to Beth or I, and we'd be happy to give you more information on that. On our website, ISI-Stats.com, we also have a link to our hour-long webinar on teaching online with simulation-based inference, or SBI, that we gave just 2 weeks ago today. And you can learn more there. There's also the SBI blog, Simulation-Based Inference blog. I haven't talked as much about that yet, but if you go to that URL, causeweb.org/SBI, we have over 50 different sets of blog posts from instructors around the country and around the world as how they're using simulation-based inference in their classes. I also have a comprehensive frequently asked questions section with the top, I think 50 or 60 questions I've got at workshops over the last few years with my responses there. So I'd encourage you to go there, poke around, and learn more about teaching online as well as other SBI related topics. So I want to just take a couple minutes to talk about assessment, really with two different ideas in mind. One is, I've been talking for a long time about why we think this is a good way to teach and how to do it. But then there's the question of, well, does it work? I told you early on, I had gathered assessment data on my students and was really discouraged by the fact that it just seemed like my students weren't learning very much. When we benchmarked the students from the beginning of the course to the end of the course, oh man, they didn't grow very much. Unfortunately, that's the case in most people's statistics courses. What we're showing you on the screen here are just a couple questions on understanding and interpreting the role of p-value in establishing research evidence, and showing you that, there are specific topics that this approach is going to sort of get most of your students to now understand. That's the blue, whereas in a traditional course, they don't. We've got some published research on this, a number of published research studies. One of them there by Beth and I and some others demonstrates that first-time instructors do nearly as well as more experienced instructors teaching this way. We know we hear from some folks who've never taught this way before. I'm a little intimidated by some of these ideas. How do I do this? Turns out that students in those courses do nearly as well. We've got a number of other published studies looking at student retention of the concepts after the course, what that looks like. Student groups who come in less prepared. Just published a paper on that last year that showed that, students who come in less prepared, this actually does quite well with those groups of students, and a number of other papers all on our website, freely available there. Most of those are published in journals like the Journal of Statistics Education, Statistics Education Research Journal, and some others. Another question we get about assessment is, okay, so you can say, okay, some of the data suggests that it works. How do I actually assess my students on a test or something like this? You show them these computer applets and simulations. What does this look like? And so we found that, this does work. Here's a couple examples of the kinds of questions we can ask students on exams. And obviously there's lots more, and in our Wiley system, we've got lots of sample tests and quizzes and test banks and things there. But here's an example. Reader wrote into the Ask Maryland column in Parade Magazine to say his grandfather told him that in 3/4 of all baseball games, the winning team scores more runs in one inning than the losing team scores in the entire game, something known as a big bang. And so this seemed kind of high to Marilyn, seemed kind of high to the person who wrote in. So a statistics professor looked at a sample of 45 Major League Baseball games. 21 of those 45 contained a Big Bang. And so the question is, we can now kind of give students a setup and then ask them a number of questions about this, what ends up being a single proportion test. So I want you to think about a few things. First of all, we want students, even on an exam, to have kind of this sense that statistics is more than just crunching a few numbers. Statistics is an entire research process. So let's give them this setup, this whole, ask Marilyn, blah, blah, blah thing. Then you see here with assessing students, we ask them a series of conceptual questions. What's the observed sample proportion? Is that number a parameter or statistic? State the null and alternative hypothesis. And then what we show the students, and this is really one of these, I think, when I first realized I could assess this way, kind of a light bulb moment for me, realizing that I could do the simulations ahead of time, screenshot the applet, put it on the exam, and ask students to interpret it. And so, for example, in this case, we're asking students, what would you have put in the applet to generate that simulated distribution? So you don't actually have to have students using the technology on the exam. Some people using this approach do have students use technology during the exam. I tend to be a little more where I just say, you know what, a pencil and paper exam is just fine. I don't want to worry about technology not working or cheating or all that. So here's one approach I have. Another thing I'll do, it's not a question on the slide right now, is I might have students say, circle where the p-value is. And that question I've really come to appreciate. It's not my own, it's somebody else's from our group who came up with it first, but I just really like how it's so much more helpful to me to know that they really understand p-value if they have to circle where the p-value is in this distribution. They need to know what the statistic is. They need to realize that p-value is more extreme than one-sided, two-sided, and visually represent that, oh yeah, that's in the tail of the distribution or it's not. So that's one type of question. Here's another question just meant to be an illustration of, sometimes on my exams, I'll be asking students to explain how they would do the simulation. And so prior to this question that's on the screen, we would have given students a little setup and say, how would you do a simulation study to analyze this? And I don't want students to say, well, I'd go to an applet. No, what we want to know is like, how many cards would you have? How would you, what would you do to them? How would you deal them out? And then every time you deal them out, what are you going to compute? In this case, it's relative risk between two groups. And, question C, where do you expect the simulated null distribution to be centered? And how do you find the p-value? And what does that p-value mean? So another way of assessing simulation in a traditional exam setting.
And this could be a situation where maybe they haven't done much with relative risk in class, but just seeing if they can apply it to this new situation.
That's a great point. And really goes back to that thing we were talking about a minute ago with comparing the medians, right? Where this 3S process for assessing statistical evidence, statistic, simulate, strength of evidence, gives you tremendous flexibility as to what your statistic is. And so as Beth just pointed out, yeah, I mean, here you go. On an exam, can a student apply that 3S process to a new context here on relative risk? So as we sort of wind down the main presentation part, we have blocked out an extended Q&A time. I know Beth's been answering a lot of those questions as we've gone, which is great. It'd be great to go back to maybe a few of those so everyone gets to hear the answers. And I encourage you to get your questions there in the chat window. And we will hang around for as long as we need to and continue to answer questions here. While you're getting your questions in, I will just remind you of a few things to learn more. First, that website, ISI-Stats.com. That has links to the curricula, but much more than that, it's samples for your students. It's all the links to the applets. It's all the data sets. It's a series of videos and other instructor resources, links to the published papers. That's all there. We've got the blog site, causeweb.org/SBI. We have a Facebook group that started not that long ago. We'd love for you to join, ISI-Stats there. I also am on Twitter. Would be happy to have you follow me, both the Facebook group and on Twitter. We're trying to post stuff that we're doing in class, interesting data sets. I posted a week and a half ago on interesting use of one of the COVID-19 data set studies that you could do a Fisher's exact test with, which is one of the simulated methods we use in our class. And of course, by email is just fine. Any follow-up questions for either of us or anything at any time. Also want to acknowledge the National Science Foundation and a few grants we've had to help fund both the development of these materials as well as some of the assessments and such.
I'll add two things to what you said, Nathan. When you're going through the assessment, and let us know if you'd like to see more examples of that, I would say the first graph you were presenting was how our students do on the types of assessment questions that have been out there for a while. And then the last two examples were more different kinds of questions that you could be asking students. So we're kind of looking at both types of questioning. And something that maybe you didn't highlight in the textbook that I think is a nice feature is every section has both a previously worked out example in detail and the guided exploration. So instructors can choose which one or go back and forth, but students always have kind of that backup exposition if they didn't get everything from the guided exploration as well.
Yeah, I'm glad you pointed that out. And I think it just gives instructors a great deal of flexibility. I mean, I know a lot of instructors say, man, I've never really taught in this more active learning way before. It's kind of intimidating. Well, then you can do the other kinds of approaches, a more interactive lecture style for a while and just dabble in that active learning style while you build some proficiency there. And even for me, I know that a more, we'll call it guided discovery approach, turn them loose approach is great. And I use it a lot of the time, but sometimes I'll change things up just to keep things lively in the classroom. And I think the materials, like you said, Beth, are quite flexible at allowing either of those sort of pedagogical styles. One of the questions that came in was, how is our simulation-based inference approach maybe different than some others that are out there? One of the others that's out there is what we call the Lock 5 book. I think it's Unlocking the Power of Statistics. That book also uses simulation-based inference. I'd say a couple of key points of distinction there. One is that the order of concepts in the Unlocking the Power of Statistics book, the Lock 5 book, is a little more traditional. So starting with descriptive statistics, moving into sampling distributions, and then inference. But when they're doing the inference and the sampling distributions, they're making use of simulations. And so that's sort of both a similarity in using simulation-based inference, but then also a difference in terms of the order of concepts. Again, one's not wrong or the other one right. I particularly like our approaches. You might not be surprised, but in starting with these sort of what we'll call the pillars of inference and getting to some of the key ideas early, and then revisiting them and spiraling over them as the semester goes on. Another distinctive there is, I think, some of the guided discovery activities, and that's something that, like Beth just said, we have those in every section. We also have more traditional exposition, fully worked examples, motivating the ideas. I think that just gives you some more flexibility in the classroom as to how to teach the materials and use them with your students.
A couple of questions have come in. Kate was asking about two-year college articulation agreements. And I think we found that that hasn't been a problem because, as Nathan illustrated, they do get to the items that you're used to seeing on the syllabus, like the t-tests and the chi-square, even the ANOVA and regression. One place where we may sometimes have some holes is in more traditional probability, because that can still be on some articulation agreements. A lot more of that is in the AP version of the book, but I know two-year colleges don't want to use a version that says high school or AP. But what Wiley is doing now with their ebooks is making it much easier to maybe just grab a chapter and add that to what you're presenting for your students. I don't know if you want to say anything more about that, Nathan.
No, I mean, I think you've said it well, that now that we have a full probability chapter in our pedagogical style, it's part of the AP curriculum, but in the second edition, it's going to be even easier to just essentially assemble your own curriculum. I'll say the same thing about our second curriculum. I know we've got an institution right now that's using these, and they like our multiple regression chapter, which is formally in our second course, but Wiley's been flexible about allowing them to pull that in to their first course. And so we're hoping, and this is just kind of the era we're entering into with sort of, ebooks. It just gives you, the instructor, a lot more control over sort of what topics you want to cover. Brings up a question that Marjorie answered here a little while ago on goodness of fit, something that will be in our second edition. great question about, goodness of fit as a way of starting off a course as opposed to a one proportion test. We've actually been talking about this. It came up recently in one of our author brainstorming sessions about whether that might be the way to go. We've talked about that. We anticipate within the next 2 to 3 years having an introduction to biostatistics book out there, and that's one thing we've talked about there, just given the relevance of goodness of fit tests in a biological setting. So I agree. My intuition. I'm excited to hear you say you've done that with your students, because we were thinking along the same lines there as well.
Another thing with the applets is Nathan showed how to overlay like a normal distribution. Like with the one proportion, you can also put an exact binomial distribution next to it. And so then you have a lot of flexibility of how much detail you want to go into the binomial distribution, if that is something that's required on your syllabus, versus, yeah, we could all get the same answer. There's some mathematics behind it, don't worry too much about that. Or, again, students may surprise you and ask to want to see some of those details when they see why they want to do those calculations, maybe a bit more in context. And I think there's also a lot of flexibility with, are the applets the only technology that are used or not? I do sometimes teach a course where that's the only technology used. One thing we have added to the applets is a little checkbox where you can see much more traditional looking computer output. And so sometimes I may just give them the output and expect them to be able to interpret it. Or sometimes we'll do something in an applet where we get the interactive dynamic visual, and then we'll go, okay, let's see how to do that in Minitab or JUMP and make sure you're getting the same answers. But hopefully once they get the output in Minitab or JUMP and you ask them what that p-value means, they can go back to the visual in the applet and says, oh, well, if I did this a bunch of times, how often would this happen?
Yeah, and I know you're using those technologies out there. Here at DORT, we do some R experience with our students in the first course. We don't introduce that to the students until a little way into the semester, and really try to use it in much the same way that Beth said. For us, it does become a little more prominent in a second course. But I'm just increasingly convinced that if I really want my students to understand the concepts, then these conceptually focused applets that we've showed you today are the way to get at those concepts, and that then the statistical software, whether it be R, JUMP, Minitab, whatever, can really be a tool to execute. But that, in a statistical computing course, like we have an R statistical computing course for our stats majors and minors, that's the place to really get after it. At least that's my thinking. I want them to have some proficiency coming out of my intro stats and intermediate stats courses, but not make it the focus.
And David also raised the point about teaching descriptive statistics just in time or along the way in the context of the full research questions. So even though they may be getting to a p-value at the end, there's great opportunities to talk about some of the data exploration at the same time. I don't know if you want to say any more about that.
Well, I think, yeah, I think it just gets at that 6-step approach in that, I don't want to say every time, but man, probably 99% of the time I'm going into class and we're talking about a study, we're talking about the entire 6 steps. And so that is going to include descriptive statistics. And it's also going to include discussing why the researcher do the study in the first place. And importantly, at the end, we're going to pull back out of whatever concept we're learning for the day and really do that look back and ahead. What did we learn? What were the limitations of that? What would you want to do next? And I really just think that to kind of amplify something I said earlier, those opportunities at the beginning, step 1, and at the end, step 6 of that statistical investigation process, I think are key opportunities to engage those students who, are just going to be at the lower end of your class, who are easy to sort of disconnect during class and say, oh, it's over my head, I'm not getting it. To pull them back in those times, I think is going to continue to build confidence. And I think that's going to lead ultimately to them having better learning outcomes on some of the more statistical concepts as well.
Do you want to say any more about changes to the second edition with respect to visualizations and data exploration?
Yeah, so that is something that in this second edition, which will be coming out in January of 2021. So we're wrapping up some of the page proofs and all the stuff now. We have worked, and so that one multivariable applet I showed you here a little while ago, where you're dragging another variable over and you're getting, the colored scatter plot. That's something we're starting with students, essentially in the first week. We want them to do even more to appreciate multivariable thinking. I think it's always been there in our curriculum. I think one of the things we've tried to do, I didn't talk about it so much today, but this idea of emphasizing the importance of a randomized experiment, and how that leads to your ability to say a cause and effect conclusion, and how that's different from an observational study, and then brainstorming about confounding variables and these things. I think it's always been there. I think we've been trying to do even more emphasis on that, setting students up for going further, whether it's a second course in statistics in your department, or whether it's a client department, or just frankly, reading the newspaper and reading scientific journals, outside of class. Just this idea that yes, the world is very multivariable, and trying to be more purposeful about some of that throughout the course.
I think we also added some questions where the descriptive statistics may be as far as you get, because that may be enough to answer the question, or maybe it's not a situation where it's appropriate to go on to inference. And so making sure students see those examples as well.
Absolutely.
Another question that came in was about a help button embedded in the applets. And I have 3 answers to that. The main answer is no. Partly that's one way that we keep the applets kind of free and not too tied to a particular curriculum, is they're kind of bare bones on just what the applet does. But then the learning activity that goes with the applet is really kind of the critical part. But I did post a link for a little demo of one of our applets that shows how you can embed your own instructions in a table box on the side or something like that. And something Nathan didn't show in some of the applets, where you're pasting in data and the applet's computed a statistic, and you go to find the p-value and you make a common mistake, like you put in 0 rather than the statistic to find the p-value. The applet knows what you're supposed to put in, and instead of just spitting out a correct answer because you pushed a button, it'll give you a little warning message saying, I don't think that's the answer you wanted to put in here, but I'll go ahead and give you the calculation, but ask you to think about it. So instead of just kind of too much of help buttons, we try and do give some scaffolding so students don't get too far off track if we do see that happening. Another thing that we'll try and make sure is that ISI-Stats page is there is an applet guide that we are continuing to update that shows you some of the maybe hidden features in some of the applets that you might not know about just by looking at it. So if you have any questions about anything like that, feel free to contact us as well.
I'll just say one more thing, Beth. The applets went through and have gone through and continue to go through such a development process where feedback from students goes into their creation, that I know, maybe early on we were getting more student questions than we do now, because I think a lot of those common mistakes, you've done things like you just said, Beth, with that little, kind of warning message. And, where are students not knowing where to click next and such, and then trying to be purposeful in changing the way the applets are laid out and the words that we're using there to try to minimize student questions. And I can just say, as a user of the applets, that I've just been so impressed by the lack of student questions. That did come up, but there's not nearly as many as you might think. So Kate's question, how do you get the stories behind the data in the applet? That's a great question. Some of those, probably the majority of them are going to be, if you go to some of the sample curriculum materials, they'll be on the ISI-Stats page. A lot of those sample curriculum materials that you can get for free to try out are related to the data that comes preloaded in the applet. So the one I showed you on the sleep deprivation is what that study was, the 21 people who were in the 2 groups that we compared. I know that's one that we've shared before.
And those are nice too, because they're all based on genuine research studies. So you can often get the article, or, how you use the data is totally up to you.
Yeah, that's a great point. You mentioning that makes me want to mention another thing we've done in the curriculum, which is by tying it to real published research articles. As you said, a lot of those are freely available. We do have some additional homework exercises that have students go read journal articles that we've pre-screened, In the second edition, we're making sure that all those articles are publicly accessible, so freely available anywhere. And then we have a series of questions we can ask students, so you can assign these homework exercises that really get students reading journal articles, which I think is just awesome for intro stats students. We've made sure that, you know, these are articles that are accessible and don't get them in over their head in terms of technical speak, and really reinforce things they're learning in class, but trying to build that proficiency at reading the scientific literature, I think is pretty exciting.
Well, a point I tried to make earlier is we're trying to get the point where students understand the idea of a p-value or the idea of a confidence interval. And so when they do see it in a published article, they may not understand exactly how that was arrived at, but they know what to do with it and they know how to interpret it. And I think that just gives them such a feeling of empowerment and just the ability to engage with the research.
Yeah, David's got a great question. You know, do we get into some of those practices to avoid, you know, bad statistics kinds of stuff? Yes, and this is one of the other, we've reordered that a bit for our second edition that's coming out, combining some things that were used to be in chapters 2 and 3 into some sort of a more focused section or set of sections in chapter 2. But yeah, I mean, talking about what happens when sampling goes wrong, and talking about some of the classic studies that are out there with bias sampling, and also, you know, confounded experimental design and what the implications are. And then I think we've got a very robust set of homework exercises to support that, where students can walk through a number of different real scenarios and critique how data was collected, how questions were worded, and, you know, where all these different sources of bias and confounding can sort of creep in to your study.
Another thing I would say is on our website, and we'd love to hear from people who've been sharing ideas already, is assigning projects in the class as well. And we do feel that that's very feasible, that students can analyze the data by the end of the course. Half of them choose simulation, half of them choose theory-based. You know, they kind of have both options by the end of this course. So I think there are some project ideas on our website, and somebody mentioned earlier the islands is probably getting a lot of attention right now because that's a virtual environment that students can assign subjects to treatments or can do survey questions and learn a lot of these principles through their own data collection efforts as well.
Yes, I think, Beth, we've got links to those project materials off of our Facebook group. I think those also are somewhere on our ISI-Stats.com page as well. Well, it's been a pleasure chatting with you all today and hearing from your questions, and encourage you just one more time, the two websites, isi-stats.com, causeweb.org/SBI for the blog. Feel free to join our Facebook group, follow us on Twitter, email us. We love talking about this stuff. We'd be happy to answer questions, share more information and resources. I will just reiterate that we have recorded this webinar, and we will be sending it out, sending out a link to it here within the next few days to the email address you registered with. And so to your point, Ron, I think that gets at how you'd have access to the slides. We'll also try to get just a basic copy of the slides on our ISI-Stats.com page with the other workshop presentations.
And the recording should come with transcription as well as a text file for the chat, I think.
Wonderful. All right. Well, I hope you all have a wonderful weekend, and we'll talk to you again soon. Thanks.
Thanks, everyone.